This video covers the introduction to Chapter 22, the management of bond portfolios. Basically, we've been assuming a lot of information about equity portfolios with stocks, and then we talked about futures and options. Now we come to the other side of the equation where we look at bonds and how they could be used and how their prices are determined. So basically, the return on a bond has two parts. It depends on two things: interest income and capital gains or losses that are caused due to a change in the price. Okay, so interest income comes through your coupons and so on, and the price changes happen due to two reasons. Okay, the first one is the passage of time. It's just how many years are we left to maturity. Based on how much time is left, that's going to affect what price that bond is trading at. And the other one would be a shift in the yield curve. So the shift in the yield curve is, if you remember, the yield curve is the plot of interest rates or yields against maturity. And so if that yield curve suddenly shifts or moves around, that changes the expectations of all the participants in the market, and that would cause a change in the bond price as well. So we're going to make two assumptions that'll make it easier to demonstrate all these calculations we're doing. And just so you know, we are assuming that interest is paid annually if we have any interest, and we're assuming a flat yield curve. That means all the spot rates are equal to the same interest rate I. Okay, that means usually yield curves are either trending upward, or if they're inverted yields, they trend downward, which just says that as the maturity, if it's a normal yield curve where the interest rates are sort of tending upward, as the maturity increases, as we get to a longer and longer term bond, the interest rates offered increase as well. Well, the yields increase as well. But we're assuming a flat yield curve, which means it's just a straight line. The interest rates are the same no matter what maturity we have. So let's first talk about price changes due to the passage of time. So we'll assume a flat yield curve with the I equals 10%. That means that regardless of what maturity bond we have, the yield is always 10%. Okay, how do we value an asset when there's certain time left for that bond? We take the present value of that asset. And if you remember from 3310, present value is just the future value divided by 1 plus that interest rate, if it's a pure discount bond. Okay, if there's no other cash flows coming into play, we just take that future value. Bonds are usually priced at $1,000, and we discount it back by the number of years we have left, or the number of time periods, and then we're going to get what the value of that bond is at that particular time. So we're going to consider a pure discount bond. There's 3 years left to maturity. So let's say where it's something like saying we're at year 0, and we have a 3-year bond. We're trying to find what's the price at year 0. Okay, we're going to discount it back 3 years. So like I said, the formula is the future value divided by 1 plus the interest rate to the power whatever number of years we have. So future value is 1,000. Interest rate is 10%, which is 0.1. So 1 plus 0.1 raised to the power of 3, because we're discounting 3 years back. So that's basically doing 1,000 divided by 1.1 to the power of 3. And that's $751.31. Okay, we'd pay $751.31 for that bond if the interest rates are 10%. And there were 3 years left to maturity. Now, what happens to that bond price? So we're looking at the passage of time, right? So now we've moved basically from year 0 to year 1. So there's, or whatever years, if we have 2 years left to maturity for that particular bond. Okay, if there's 2 years left to maturity, now we're only going to have to discount it for 2 years with the same numbers, except that 1.1 now is going to be raised to the power 2, because we're discounting that $1,000 just 2 years, not 3. So if we do that, 1,000 divided by 1.1 to the power 2 is 826.45. So we can see that the price has changed. Okay, as the maturity is getting closer and closer, the price is actually going closer and closer to 1,000. Since it's a pure discount bond, the price will keep rising towards 1,000 as the maturity gets closer. So this price change happens over the year, and we're trying to find what is the price change. So the price change, we just take a subtraction, right? What was the new price? What is the old price? So the new price minus the old price is 826.45, this number, minus this number, minus 751.31, and that turns out to be a positive 75.14. This bond price increased by 75.14 over that year. What's the rate of return then? The rate of return should be, if you think about it, should be that 10% because that's how that bond price is changing. But we'll calculate it to show it's the same thing. So we take that difference. So remember, whenever we're trying to find a rate of return, a percentage, a change in return, and so on, we do new minus old divided by old. Okay, so we have new. The new price is 826.45 minus the old, which is 751.31 divided by 751.31. We already calculated this difference, so I'm putting that up there. 75.14 divided by 751.31, and that turns out to be 0.1. And that is the same thing as 10%. So we've calculated the rate of return due to the passage of time. So this is a key factor. Because pure discount bonds do not pay interest, okay, they're pure discount, right, where there's no coupons assumed, the full return is due to the change in price. Okay, the entire return that came out is due to that change in price, where the price changed from 826.45, from 751.31 to 826.45. That's the entire return. Now, what if there's an unanticipated price change? So we just talked about price changes due to changes in time, passage of time. Now, what if we're talking about changes in the yield curve? Okay, changes, a shift in the yield curve. So prices can change due to future expectations concerning the interest rates. Okay, so people have expectations about the interest rate that guides the yield curve. And if these expectations change, that would cause the yield curve to shift. And if they were unexpected, it's an unanticipated change, that causes a change in all the bond prices. So this is how a flat yield curve looks. So if you remember, I said a yield curve is just a plot of the yield against maturity. And we're assuming a flat yield curve. That means regardless if you're at 1 year, 10 years, 30 years, whatever the number of years to maturity is, we're still at 10% all the time. Okay, it's a flat yield curve. And now there's an unanticipated shift. Suddenly, instantaneously, this moves up to 14. Okay, so this sort of translates. It's called a parallel shift. Okay, and now our yield curve, instead of being at 10, is now at 14. Okay, and so the new flat yield curve is at 14. So we're calling that a parallel shift from 10% to 14% yield. We're going to see how that affects the bond prices. Okay, so we're saying the shift is immediate. That's key because an immediate shift would be that something that's unanticipated. The interest rate is now 14%. Okay, so we're going to calculate the bond price based on that new interest rate and see what the difference was. So we call it P3 prime, just like a new P3, where we're saying there's still 3 years left to maturity. So instead of dividing by 1.10 to the power 3, now we're going to divide by 1.14 because the interest rate is 14%. So we still have 1,000 divided by 1.14 to the power 3. And that turns out to be 674.97. Okay, 674.97. We're going to compare with our original P3. What was our original P3? That was this 751.31. We're going to see what kind of price change happened now. So if we compare and we just subtract away the old price with the new interest rate price, we see that 674.97 minus 751.31 is minus 76.34. Okay, this shift in the yield curve, that 4% shift in the yield curve, describe the $76 loss in the price at that same time period. Okay, so without changing anything else, the shift in the yield curve caused the price to drop by $76. However, think about it. If we were able to make better expectations than other participants in the market about how future interest rates would shift, we'd be able to calculate these price changes easily and put all our money into bonds with the highest total return. However, we're unable most of the time. I mean, we're not geniuses. We're not better than everybody else in the market, or else things would equate. We'd be trillionaires at that point. We are unable to predict these shifts in the yield curve. Okay, we can't predict instantaneous shifts better than somebody else. And so, what can we do to help with that? The best we can do is calculate the sensitivity of each bond to a shift in the yield curve and make assumptions based on that. Okay, we could see how sensitive is this bond to a change in the yield curve. We use that information to make these predictions, and that will be presented in the next video when I talk about duration of a bond.